Guys, don't forget this tool. This tool is necessary.
Tracer.
The tracer. No? The tracer. What is the function?
Find wires.
Find opens and
Follow
shorts.
wires. Yeah, simple. You install at the end of the wire this one to the negative bus bar and this to one end of the wire. The wire with no power. And with this, this is very important. I don't know. Don't forget this one, guys, to check the condition. Okay, look at this.
Pedestal.
Okay, this is the condition of this this building. Neutral, ground, and hot are solid. Is good. If for some reason the ground is not connected, will be off the ground. Or if the ground and the neutral have a they are intermittent, both of them, flashing. In this particular case, they are okay. Let me check what happened with the voltage. 122.2. It's a good voltage. Look at this. This outlet is for 15 amps and is used only 7.5%. Of the 15 amps, only in this moment is used only 7%. Okay, and what is the consumption in this moment? Drains of current? No, 0. The resistance of the circuit, 0.32. That's good. In the course of corrosion, we are going to learn that if that resistance, that resistor should be in the ground line around 0.2. Yeah. Once again, hot, neutral, and ground good. You don't have reverse polarity. That's good. This is a great tool.
Wait, what's the name of that tool again?
The
short test.
Sure test. Yeah.
For a pedestal, you can.
Look at this. The peak voltage is 174. The peak voltage. That's good. Normally it's around 170. The frequency, 60 hertz. The air and yeah. And this is the leak of current. Nothing. It's good. That's great. I recommend this tool. You remember this one?
It's the
Stick it in the engine room.
electromagnet.
Yeah.
To identify electromagnetic interference, no?
That's the gush.
Yeah. This is the gauge meter. Sorry. Yeah. When you approximate to a motor or generator running, increase. Okay. That's other important tool. I recommend, my friends, when you have a chance, try to buy an envelope like this. This one have a lot of terminals, a lot of because in some cases you need to introduce your voltmeter in a pin, in a small hole, or in a specific terminal. You have adapter for different type of to convert from one type of terminal into other one. Yeah, millions of adapters, depending if you need to check the pins in the outlet of a computer or yeah, and a lot of alligator cables, no? Different colors, different lengths. You need a lot of alligator cables. A lot. We are going to check to refresh quickly the procedure to check a capacitor. This is a capacitor. In what function I am going to use my capacitor? Volts and the function capacitors. Capacitors is the yellow one. Yeah, straight and curved. Yeah, that's the capacitor. Okay, and I'm going to select over there. I am going to select the function. The yellow one is what is the unit of capacitor? Farads, micro, pico, or nano. In this particular case, 0 nanofarads. Okay, all right. I am going to check. I am going to read in the label of the capacitor. This one should be in between 21 and 25 microfarads. 21 and 25 microfarads. Yeah, okay, I am going to check.
Oh,
Of
you
course,
have-
you,
you have
you
to,
need
like,
discharge.
discharge.
This is the charge. Okay, you discharge over there and you read in between one and the other one. How much is the reading?
38.5, 40, 38.
38 microfarads. And the label said should be 20 and 25. Is good or not good, the capacitor?
No.
It's damaged. The capacitor is damaged. The reading is 38, and this one should be maximum 25 microfarads.
So how
In this moment, I have 38 microfarads, and the reading should be 25. Bad capacitor. I need to replace the capacitor. That's the only way. That's the only way. Be careful with the technician that said, no, to check capacitor, I check continuity PP, no PP. No, no. Only with the multimeter in the function farads capacitor. Okay? All right. Other element that you need to verify every day is
relays and
relays, no? Relays. How you check this relay? You have continuity between this and this right now?
No.
No. No? If I try to check continuity, beep, you don't have continuity. Let me demonstrate. What is the function of continuity? Ohms with sound, no? Okay, let me check if I have continuity here between this and this. I have continuity. It's supposed that in between this and this, I have continuity right now? No. No, because it's normally open. If I bring a signal 12 volts, 6 volts, 24 volts, what happened? And I have continuity. That's the process to verify this one. How you check this one? What is the number of this one in the button? 30.
30. Oh, yeah, 30.
This and this?
86.
85 and 86. What is the name of the middle one?
87A.
87A. And this one? 87. In normal condition, in this moment I don't have power in between this and this. Which one is normally closed? Between this and this, or between this and this? In between 30
30 and 87A.
87A.
and the middle one, no?
Yep.
That's okay. How much is the you have continuity between this and this?
No.
Nothing. If you power it, yes. That's okay?
Mm-hmm.
What happened with the continuity between this one and the middle when you power it? Open.
Yeah.
That's it. That's the process. And you hear, no? You need verify a lot of. You enjoy the project when we design the rectifier. You remember? You did the rectifier, you soldering, and you convert 120 volts into 14, no?
Yep.
What?
What's the circuit?
Yeah, nice, no? In the future, in the diagnosis of generators, harness, engines, in outboards, you need to create a rectifier. Because especially in outboards, on the flywheel of the outboard, they have magnets, and the flywheel produce AC current. And after that, in the harness of the outboard have a small rectifier to convert in 12 volts for the engine. In some cases, that rectifier fails. And you say, I don't have power in the harness. The flywheel is spinning, is producing AC current, you remember? Magnets. But I don't have power in the harness. And what is the symptom? You remember what happened when you don't have power in the harness? You remember we did the diagram, the wiring diagram of the harness of any type of engine, gas or diesel. You remember? You remember what is the symptom when you don't have power in the harness and you remove your finger from preheat, the engine shut down.
Dials know this.
Excuse me, because the alternator is not producing power. No? in this particular case the outboard, the flywheel is not producing power, or is producing but is not rectified into DC. For that reason, you can buy those rectifiers. Look at this. This rectifier in one diagonal is AC, in the other diagonal is DC.
So that's 4 diodes, like
Internally have the diodes.
Okay.
It's nice, no? You can buy this one, and you install here AC current, and you read DC here. They have the mark AC and positive for DC. This is in cases that you need rectified AC current into DC. Your alternator in your car internally rectified the AC into DC. They have one of these internally, one rectifier, and after that, with the voltage regulator, keep the output voltage constant. Okay? All right, great. Rectifiers, relays. Okay, you remember what is this? This is an a.c.r. Okay? What is the difference between this a.c.r and this a.c.r? This one is one input, two.
Outputs.
That input is coming from
Positive.
alternator or battery charger. Yeah? And this one is positive of battery bank number 1 and positive of battery bank number 2. What is the function of this?
Even level the charge.
Balance the charge in both battery banks. a.c.r. What is the difference between this and this?
Number of inputs and outputs.
This one have two
Two
inputs
two
and
engines.
3
Output.
outputs. With this, I can connect alternator 1, alternator 2, and 3 battery banks. Oh, nice. I love it. There are other ones with 3 inputs and 4 outputs. Okay, guys. What is the difference between this and this? This is an
Inverter.
inverter. And this is
The battery
Battery
a
charger.
battery charger.
Oh, a separate charger. It's not
This
built
is a
in.
battery charger, exclusive battery charger. What is the input of the battery charger? The input here is
AC.
AC. And internally have the bridge of diode, and produce 1 negative and 3 outputs positive. This is a rectifier. It's a big rectifier. No? That's okay? This is a battery
Charger.
charger. What is this?
Inverter.
The inverter. This is,
Positive and
this
negative.
is, this is
DC.
the input, DC. That positive and negative is coming from the battery bank. That's correct? And in the other side, they have AC output, AC output, AC output. This is the AC that is going into the battery switch selector and is going into the main AC panel. However, this element have AC input, input, and input. Hot, neutral, and ground input. That current input is coming from
The panel.
The breaker.
from one breaker in the panel for what? Input of AC? That element is designed to receive DC in one side and produce AC in the other side. Those AC outputs. What about the bottom one? Inputs.
For its own charger.
Because internally that element have your own battery charger to keep the battery bank fully charged. That power coming in is coming from one breaker in the AC panel. Mr. Lopez, when this element is producing AC power, this element receive AC? No. When this element is producing AC power, the AC input is closed. The AC input open to receive only when the AC panel is powered from short power, not from the same inverter. That's okay? For that reason, what is the name of that breaker in the AC panel? The breaker that is coming in here. What is the name of that breaker?
That
inverter slash charger. It's only for the battery charger of the inverter. This is not to activate the inverter.
Correct.
Where you start the inverter? In a switch selector that you have from the battery bank entering here, and additionally from this button to start the inverter. That's okay? To start the inverter, you don't need to activate any breaker in the AC panel or DC panel. This is completely independent. This is a source of power. Good? What is this element, guys?
That's galvanic isolation.
Galvanic isolator. Some people confuse the galvanic isolator with
The
the a.c.r. This is an a.c.r. This is not a galvanic isolator. I found it some years ago. One of these installed here with the one ground entering here and the other ground continue here.
Ay, Dios mío.
I have the picture. This is not a galvanic isolator. The ground coming from the chart enter over there, and after that continue into the grounding bus bar. All right, you separate the ground, you discharge with a cable, and you check with the multimeter in the function. Diodes. In one direction, the reading should be from 0 to 0.9, maximum 1 volt. If the reading continue going up, disconnect your multimeter because this is damaged. After that, you discharge again and you switch the cables on the multimeter in the function diode, and once again 0.1, 0.2, 0.3, 0.9, maximum 1 volt. Yeah, this is an indication that the galvanic isolator is in good condition. Ready? Other element that I don't have here is the isolator transformer. Some people say that the galvanic isolator and the isolator transformer is exactly the same. Is the same?
Nope.
No, my friend. It's not the same. What is the function of the galvanic isolator?
Add current.
Look, this is the short power connected to the pedestal. The pedestal is here, no? Block the intrusion of bad currents through the ground in my boat. Block. If the pedestal, if the marina is contaminated, that contamination enter in my boat? No, because this filter blocks. That's the function. Block the intrusion of bad DC current through the ground. Right? Okay. What is the function of the isolator transformer? Clean the signal. Clean what?
The signal.
Noise, interference. Yeah? If the signal is entering with too much noise, after that the signal is completely clean. How many, in relation with the amount of turns, coils in the primary coil and in the secondary, the isolator transformer is the same amount of coils in both sides, in the primary and the secondary. You remember that? What happened if I have a step down transformer? This is the primary coil and this is the secondary.
Secondary is
In the secondary you have
fewer windings.
less turns because it's a step down. In a step up you have more coils in the secondary. Simple, no? Great, guys?
Yes, sir.
Good? It's clear? The future, no more confusion. This is a galvanic isolator. Okay, which one? In between galvanic isolator and isolator transformer is mandatory, is necessary to prevent corrosion.